right, this is section 4.7, number 25, and we're told to solve and to identify all double roots. So we'll see what that means here in a minute. Okay, if they want us to solve it, what we have to do usually is factor it. And that seems to be what they're asking us to do here. This isn't a section on quadratic formula, it's a section on factoring polynomials. So it looks like they factored it for us, except that if you check, they didn't finish it. This right here did not get finished. So we need to finish it. So we say, okay, we're just going to write the x minus 1 down because it's a factor. It's already, there's no squares on it, so it's pretty reduced. Now we're thinking, how can I factor x squared plus x minus 2? I said I was going to get away from this, but I know some of you are still struggling. When we have something to factor, it has x squared and it has an invisible 1 out front, all we have to do is multiply to get the number on the end, the negative 2. That's our ax squared plus bx plus c. We're multiplying to get the c term and adding to get the b. C is negative 2, b is an invisible 1. The coefficient of the x is an invisible 1 here. Alright, so what multiplies to give me negative 2 and adds to give me 1? How about 2 times a negative 1? 2 times a negative 1 is negative 2, and 2 plus negative 1 is a positive 1. So I can factor using these two numbers. I have x plus 2 and x minus 1. Now, if you remember how we solve, we take each factor and we set it equal to 0. Do you notice that we got two of the same factors here? We've got x minus 1 twice. As a matter of fact, I could write this as x plus 2 times x minus 1, and there's two copies of it, so I could write it as squared, okay? We're supposed to take each unique factor and set it equal to 0. So one of my unique factors is x plus 2. I set it equal to 0. I get x is negative 2, right? If I subtract 2 from each side. When I solve that, that's called a solution, but it's also called a root, okay? So this is a root. So there's one root. If I'm going to list them, I could put, trying to make fancy brackets, but my stylus is kind of sticky. I've got negative 2 as a root. Now, I've got another x minus 1 squared. There were really two copies of it, but there's no point in me writing them both down and setting them equal to 0 separately because they're going to equal the same thing. As a matter of fact, since there's two of the same ones, I know this is going to have two roots. And what will that root be? Let me write x minus 1 equals 0. Let's set it equal to 0 and solve it to find the root. The root is 1. So I have another root, and it is 1, and because there were two copies of them, and that's why I write the square up there to say there's two copies of them, right? Then that means 1 is a double root. So if you look at how they're indicating that in the book, they're just putting DR for double root. All right, now 29, we're supposed to solve and, again, identify any double roots. Now, if you remember, when we have one of these, a factoring problem, and we're used to seeing x squared minus, maybe x squared minus 2x plus 1. But here we have x to the 4th minus 2x squared plus 1. And if you remember how we handle that, instead of putting an x here and here, I need an x squared here and here to get this to work, because x squared times x squared is x to the 4th. And when we get done with this, if you'll multiply it out, you'll see that this works to give you the middle term as well. I'll leave that for you. Okay, okay. So I'm really looking at this. Sometimes books will rewrite this. They'll say, here's what they'll do. They say, let's call this substitution, and let's let u equal x squared. And so they would say this is really u squared minus 2u plus 1. They're just trying to indicate to you that making this x to the 4th x squared times x squared really works. I'm not going to work it like this. I'm just going to tell you that sometimes they do that just so that you can see that you're really left with looking at the same numbers as you would as if we had this problem that I just X'd out over here. What I'm doing is I'm trying to multiply to get the c term on the end, the coefficient. Remember, out in front of this first term, there's no number, so I don't have to worry about it this time. These are a little easier to work. I'm trying to multiply to get the number on the end and add to get the number in the middle, the negative 2. Well, how would that work? Wouldn't negative 1 times negative 1 give you a positive 1? And wouldn't negative 1 plus negative 1 give you negative 2? It would. So we can say, oh, I can factor it like that. Now, we know we need to look at this again because inside those parentheses I've got some x squared terms, and we know that a lot of times x squared terms factor. And if you look at these, they're actually two of the same thing, aren't they? X squared minus 1 times x squared minus 1. I can keep factoring this because each one of these is a difference of two squares. Let's look at x squared minus, this is just one of them. What do you square to get x squared? You square x. What do you square to get 1? You square 1. And I need a plus and I need a minus. And since these two are identical, I'm going to have this happen twice, aren't I? Okay? So I could actually write this as x plus 1 squared times x minus 1 squared because there's two copies of each one of those in there. All right, now to solve it, I set them equal to 0. And since they're factored and I set them equal to 0, I can take each factor and set it equal to 0. Now, if you're looking, you could look back up here to think about what to do, right? There's 4 different factors, but since there's two factors that have identical copies, we don't want to do each one of those twice. So we're just going to do, let's take this x plus 1 and we'll just do it one time. We don't need to duplicate our work. So we subtract 1, we get x equal negative 1. So if I'm listing my solutions, which are called roots, right? Negative 1 is going to be a solution. But it's a double root because there were two copies of that x plus 1. You may want to look back up here to see that, x plus 1, x plus 1. So since I could have done it twice, I'm going to put dr for double root. Now normally other books don't have you do this. This book is just trying to get you to see that you do have 4 solutions here. It's just that 2 of them are identical. If you were to go graph this, oops, this thing is flipping in it. If you were to go graph this, it usually looks something like this. It might come and hit and bounce up and hit and bounce up again. And so these double roots end up being right in there. Okay. All right. We got another root to solve, though. We've got, so one of our solutions was negative 1, and there were 2 copies of it. Now look at this x minus 1. If I set it equal to 0, because we take each factor and we set equal to 0 to solve, don't we? We would add 1 to both sides, and we'd get the solution, or the root, x equal 1. But again, there were 2 copies of it. They were right here, weren't they? So I also have 1 as a solution, and it is also a double root, so I'll put 1 dr, just because the book asks you to do that, okay? All right, this problem kind of works the way the other ones have that we just finished working. I could do this. I could say, how could I think of this t to the 6 as a square? Well, wouldn't t cubed times t cubed, we would add our exponents and get t to the 6, right? And you could look down at the t to the 4th and say, well, how could I write it as a square? I could write it as t squared squared, or I could say that's t squared times t squared. Okay. You can do this, all right? Or what if that's like confusing you? Well, some books think this is an easier way to explain it. So I haven't messed with the numbers, by the way. I'm just looking at the variables here, trying to get them figured out. Some books would say, let u equal t cubed. Wouldn't t cubed squared be t to the 6, right? So that t cubed, if it's u, that ends up being u squared. Okay, so instead of t to the 6, you would write u squared, because t to the 6 is equal to the u squared here. Now then, since u is equal to t cubed, I'm not going to do that. Let's scratch that for a minute. This is going to get crazy here. Let's scratch that train of thought. Let's just go back to this one. I can divide t to the 6 up into t cubed times t cubed. I can divide t 4th up into t squared t squared. We're just trying to, what I really did there was take each exponent and divide it by 2. Okay, and I'm looking at those as squares. And I've got to think now, let's look at the number parts. There is an invisible 1 out front. Okay, so I don't need to worry about a number out front. On this end, there's a negative 10. I'm trying to multiply to get negative 10 and add to get 9, the number in the middle. Okay? What would work? Well, 10 times negative 1 is negative 10, and 10 plus negative 1 is 9. So I could factor this as saying it is t cubed plus, that's a plus 10, so I'll put my plus 10 in front of this t squared here, and I'll put this minus 1 in front of that t squared. This is a weird little problem, I understand. But this is how you can break it up. And if you multiply this out, you're going to see that this works, okay? Because I'll let you do that, though, because for sake of time on the video, I know I'm going to run out of time if I do that. Plus, we're going to not have space here. All right, I factor it. I set it equal to 0. Now, have I factored it, though, completely? No, I haven't, because if you look over here at this first term here, I'll underline it in green so you can tell what I'm looking at as I speak. Isn't there a t squared that divides out of both of those terms? There's a GCF there, so let's take it out. T squared times t plus 10. And over here, there's another t squared that comes out, t squared times t minus 1. So you can multiply these two t squareds together and get t to the 4th. At the very beginning up there, I could have factored out a t squared and made my life a little easier, but I didn't see it. I'll redo this problem in a minute doing it that way, but let me finish up what I've done here. Because sometimes you start working on something and you see a way to do it, and then in the middle of it you go, oh, I could have done it another way. But let's finish it this way first. These two t squareds, let me just put them as t to the 4th. Then I've got a t plus 10 and a t minus 1. Okay, so I could set these equal to 0. Now I've got 3 different factors, right? I've got this one that I can set equal to 0, and that t to the 4th equals 0. If I 4th root each side, I'd get t equals 0. 0 to the 4th power 0, in other words. Now let me take this term, t plus 10, and I will set it equal to 0. And I can solve it by subtracting 10 from both sides. And I'd get t equal negative 10. So my roots so far are 0 and negative 10. As a matter of fact, I could list them over here. 0, negative 10. Got one more. I'll do it with purple just so we can see where I'm pulling each one of these from. T minus 1 equals 0. So we add 1 to both sides. And we get t equal 1. So my roots are 0, negative 10, and 1. That's one way to solve it. Let me show you another way that I should have done this, because isn't the rule on factoring that we should always pull out the GCF first? Well, I didn't think to do it, did I? And honestly, because I didn't think to do it, that's why all the scribbling over here that I did, that's why I got confused over here when I was trying to work through this one, is because I didn't do that first. So let's look at it. What if I had done that? What if I had t to the 6th plus 9t squared minus 10t to the 4th? I could have taken out t squared first. So, because that's the GCF, is t squared. Then I would have had t4 left plus 9, because the t squared would have come out, minus 10 t squared. That might have been easier to factor, because I'd had a t squared here, and then I could have said, okay, I've got a t to the 4th. Now these terms are not in the right order, are they? I probably, before I factor them, let me do this. A t to the 4th would come first. The next term down should be a minus 10t squared, and then we should have had a plus 9. Okay? So if I've got that, I could say, okay, I got a t to the 4th up there. I can split that up as a t squared times a t squared. And then I could just say I'm trying to multiply to get 9 and add to get negative 10. What would work? Negative 1 times negative 9 is a positive 9, and negative 1 plus negative 9 is negative 10. So I could have put minus 1, minus 9 here. Okay? So then I would have had, oh, look, I got the difference of two squares. I've got t minus 1, t plus 1, and I've got t minus 3, t plus 3. Oh, I'm gonna get some more answers this way, I believe. So I set t equals 0 for this one, and I can say t minus 1 is equal to 0. That gives me t equal 1. I've got t plus 1 equal to 0. That gives me t equal negative 1 if I subtract 1 from both sides. T minus 3 equals 0 will give me a root of 3, because I can add 3 to both sides and get t equal 3. And then t plus 3 equals 0 would give me